turned out that it wasn't the supply chain associated with the real hardcore technical components. We were getting the parts needed for the last cabinet just in time to make the last cabinet. So compute to edge to instrument. We have 6 projects going on where we're trying to do exactly that.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey everyone, it's Doug Black. Great to be with you again, Shaheen.
Thank you, Doug. How are you?
Good. We have a special guest today on the podcast, one of the real luminaries of the HPC community, someone who has been a witness and a participant in the recent history of HPC. We have Dr. Jeff Nichols. He is Associate Laboratory Director for Oak Ridge National Lab's Computing and Computational Sciences Organization, has been in that position since April 2009. And Jeff's appearance today is something of a valedictory because he plans to retire this year after 20 years at Oak Ridge. In his current role, he oversees the Department of Energy's National Center for Computational Sciences. And as such, he has been a key figure in the installation of Titan, Summit, and other breakthrough supercomputers. Jeff, welcome.
Well, thank you. It's a joy to be here.
So tell us about some of the bigger, most significant changes you've seen in supercomputing over the last 10 years or so as these most powerful systems at Oak Ridge have gotten bigger and more heterogeneous.
Yeah, so I was thinking about over the past decade, and I think that probably the most significant changes occurred a little bit longer than a decade ago. In 2009, actually, we were faced with making a decision about what we were going to do. We had just delivered Jaguar, which was the first unclassified supercomputer in the US to be number one on the top 500. And as you may or may not know, you no sooner get one delivered and then you start the process for delivering the next one. And so just like right now we're delivering Frontier, but we've also put in our request for our critical decision 0, which is our mission need for the machine after Frontier. So we were starting to think about what comes after Jaguar. Our plans at that time were to be leveraging the investments by DARPA HPC, where they were working on what would have become the Cray Cascade system or the IBM PERC system. The PERC system was actually supposed to go to University of Illinois, Champaign-Urbana, the NCSA, and we were slated to get the Cray Cascade system, but all of that kind of fell apart for one reason or another. There was an issue with Cray and the Intel processor, and so we were forced to reevaluate where we might go after 2009 with Jaguar. And so I can remember that there were 3 or 4 of us that got onto an airplane and we flew out to Cray in Seattle, and we went to their boardroom, and in front of their whiteboard with Steve Scott and a few other Cray folks, Pete Ungaro, the CEO, and we were just brainstorming about what could we possibly do for our next system. We looked at all the various processors that were out there, and we looked at our power utilization. With Jaguar, we were sitting at around 6 megawatts of power, and so we were trying to think what the heck we would do for the next one within the boundaries and the constraints of our footprint, and also with the technology constraints that were out there. We thought a lot about what Los Alamos had done with a Roadrunner using IBM and PlayStation 3 processors. And at the end of the day, what we decided was we were going to think about going down the path of gaming processors. And so we quickly decided that we had one of two choices to make. We could decide to work with ATI at the time, and ATI had these, they were called like North Island and South Island GPUs, and then there was NVIDIA. They had their Fermi and Kepler kinds of GPUs. In fact, they may not even had a name for those. They may be have called K20 at that time. But we went and started thinking about who we could work with and who would actually help us to get to where we needed to be if we wanted to go with the gaming processor. So we started conversations with NVIDIA. NVIDIA decided that they would make the investments to modify about 30% of their silicon to add double precision floating point and error correcting memory, and to harden some of the paths to the registers that we needed in order for us to be able to use a GPU as a scientific processor. And so we made that decision in 2009. Boy, did we take a lot of heat for that, because headquarters didn't like it, because this is something brand new, right? I mean, it was They actually moved us from a production facility, the leadership computing facility. They decided to call us a research facility for a few years until we proved that we could actually deliver something. And so it actually helped us to work through a lot of the things that we still deploy today. There's an interesting story. Maybe I can take 2 seconds and tell this story. In 2009, there was the first GTC conference. You might remember that they just had the GTC conference. And so in 2009, in the fall, I think it was the first GTC conference ever. And Jensen invited me to come out there and all he really wanted me to say was, we're going to build the world's fastest supercomputer with GPUs. And so I had my coat and tie on as a real nerd from the lab. And I walked out on the stage. Jensen, in his black leather jacket with his t-shirt underneath, calls me out there and he says, Dr. Nichols, he says, I hear you're going to use our GPUs. What are you going to do with them? And I said, I'm going to build the world's fastest supercomputer. And the crowd just erupted, just hooray. So I looked out there. It was hard to see because of all the blinding lights, but these were all like 14-year-old gamers that were watching this GTC conference. And so they all thought I was going to build the world's fastest supercomputer, run Halo or something, and so it was really quite funny. So NVIDIA did what they said they were going to do, and we did what we said we were going to do. And from 2009 to 2012, we worked on what we called the first accelerated node architecture using the GPUs, and we fielded Titan in 2012 with the GPUs. And you could think of it as an upgrade almost. We took 40,000 6-core CPUs out of Jaguar, put in 20,000 16-core AMD CPUs and 20,000 NVIDIA GPUs, each node having one CPU and one GPU. It was a learning experience for all of us.
I'll bet.
It quickly became, well, I won't say quickly. After a while, it became everybody's doing GPUs these days. And so it turned out to be the right thing to do. But that was probably the most significant change over the last decade, I think, for us.
So that sounds like both a gutsy decision because you're really taking a decisive different direction and really a different direction that had broad impact on HPC generally.
Yeah, I think so. But at the end of the day, it allowed us to get a factor of 10 in performance improvement with a probably no more than a 50% increase in power. I think we went from about 6 megawatts of power to 9 megawatts of power, and we got 10x performance improvement in sustained impact performance, which was incredible, really, in a 3-year period.
Jeff, the big thing you've been working on is the Exascale Frontier project. Would you mind taking us into the shop a bit and giving us a flavor of what you're dealing with and how it's all come together? Because I think you just hear the party line on the outside and you miss all the fun. So give us a bit of the fun of what it takes to put all this monster together.
Okay, yeah. So the fun was a combination of things. COVID really put a damper on things in terms of supply chain. And it turned out that it wasn't the supply chain associated with the real hardcore technical components like the CPUs or the GPUs or the Cassini NIC or Slingshot. What it was is the little widgets. I think some of these suppliers would call them jelly beans. These are the things that are like the little controllers, electrical switches or controllers, or the things that you would need in your automobiles or refrigerators or these kinds of things. It was just the little standard parts. I mean, the system Frontier is comprised of somewhere between 50 and 60 million parts. And we got those parts from about 500 different suppliers. And the supply chain was a disaster. And you've heard all of the things that, where we've got big ships out, container ships out in the ports and whatnot, and not getting unloaded and all of these kinds of things. But if you looked at it from just a microelectronics perspective, most of these 50 to 60 million parts were created by TSMC. So even though they were coming from 500 or 600 different vendors or providers, they were all tracing back to TSMC. And so we were all fighting for the same parts. We had to do things like go get a defense priority authorization approval from the Secretary of Energy so that we could actually jump to the head of the queue. So it was... Wow. We were getting the parts needed for the last cabinet just in time to make the last cabinet. So the last cabinet we had installed in our center in October 18th of last year. This was the 77th cabinet, and these cabinets are 8,000 pounds. When you look at how they come in on a truck, there's 4 or 5 of them per 18-wheeler. And so they started making these things up in Chippewa. This system consumes just slightly less than 30 megawatts of power. So you could build a row of them up there in Chippewa and then burn them in and then ship them down and put them on our floor and start to cable things up. But This process took a lot of time. And by the time the last cabinet came in on October 18th, we still had miles and miles, tens of miles of cables still to connect up to create the Dragonfly topology for this big system. And so that's what we've been doing. I mean, this system probably has more unique attributes than some of our previous systems. I mentioned that from Jaguar to Titan, we went from CPUs to GPUs, but it still was an AMD CPU, and we were using similar kinds of interconnects. In this particular system with Frontier, we have a brand new CPU from AMD, a brand new GPU from AMD, a brand new Cassini NIC from Cray, or HPE, and Slingshot from Cray or HPE. And so these are all brand new. And so getting this thing put together and putting it through its paces, it's taking us the usual amount of time. I would say that I think there were several people, including me, that we were hoping a miracle could occur, that we would get this complicated system put in, cable it up, turn it on, and it would work right out of the chute, and we would get a impact number, submit it, and be on the top 500 in November. Well, that was crazy. And so here we are. We're doing what we always do with these big systems. We put them together. We start to stabilize them. We go through the scaling issues associated with putting a big system like this together. And Cray HPE doesn't have the facilities really to put a system like this together and debug it. They do that here, right? They shipped us about 12 racks at a time over 3 or 4 trucks, 18-wheelers. They had tested those at Chippewa, but then they would bring them down here and they'd get them all cabled up. And then we go through all the scale up and scale out here. And so that just takes time. And so
right on.
I think Summit, we started taking delivery of Summit in June, I think of 2017, and we got it on the top 500 in June of 2018. So I think we're about where we expected to be. And, we're not late. We actually accelerated our delivery schedule for DOE. We were supposed to come in 2022, 2023 after Argonne.
Right.
And so we actually pulled ours in a year in order to deliver it and try to get the first Exascale machine in this time frame. So I think we're doing quite well, and we're quite pleased with the progress so far. And we're still plugging away, and the system is getting more stable as we speak, and we're able to run bigger and bigger jobs all the time. So we're pretty pleased with where we are.
And you've got Crusher out there now.
Oh, yeah. So we have 3 test and development systems. The ECP is the Exascale Computing Project is banging away on Crusher. And in fact, Doug Cothey is talking right now to ASCAC and telling about the good things that Crusher has found with regards to the applications getting up to speed on the Frontier architecture. So things look pretty good.
That's brilliant. Excellent.
Great. Thanks for that update. So, Jeff, what are your views on the biggest challenges the national labs and the HPC industry face as we move beyond exascale towards zettascale, the next big supercomputing milestone?
Yeah, so I have my own personal views of that. And I believe that we're going to be moving from single systems to, I'll say, distributed system or ecosystem. I tell our guys, I really want to think about going from an exascale system to an exascale ecosystem. I think we will still continue to add compute power. In other words, more and more flops per watt and these kinds of things. I think that will always be important. Even when you think about doing AI or machine learning, you're still adding and multiplying numbers if you're doing a convolutional neural net. So I think that we will continue to add compute power. But I think we are doing several initiatives here at Oak Ridge where we're trying to connect our big compute to edge instruments and then connect the edge to the actual instruments themselves. So compute to edge to instrument. And we've got big projects going on right now where we're trying to connect and automate a chemistry lab or a material science lab or an electron microscope or a neutron sciences instrument or a quantum device or, in fact, a 3D printer. So we have 6 projects going on where we're trying to do exactly that. That's the big challenge, right? How do you incorporate all of the technology that you need to seamlessly maneuver around a big, massive exascale ecosystem? Well, you need lots of technology, that gives you high bandwidth connectivity. It gives you automation. It gives you the ability to do AI on the fly, to move your data around, build models from data, deploy those models, be able to control devices, get the data back out, move it back to the big supercomputer, build new models. I mean, there's no loss of things to think about with regards to moving towards the next scale. So I think it's an awesome time to be involved in HPC. Beyond exascale, you got the kind of notion of what's happening after CMOS. You got the notion of, hey, what do these big data edge devices look like? You got all kinds of vendors out there. There's probably 120 new startups out there. You got people thinking about inference engines. I mean, it's awesome. I love it. I mean, I think that's where computing is going to be for the next decade and beyond. I think we're going to see so much more automation and discovery in ways that we had never thought about.
That's excellent. I love hearing the end-to-end picture that you just described. How do you map that to this whole discussion of general purpose computing versus special purpose computing, or maybe there's a happy medium? Is it a happy medium, or is it neither this nor that?
Well, so, I think the department is moving towards this notion of integrated research infrastructure. That's something that we've been doing. We started with things called federated instruments, and now we call interconnected science instruments. We are doing similar kinds of things, and I think everyone is trying to understand how we can actually automate many of these instruments, and COVID actually pushed us along in that direction too. How can we do these experiments from home? And I think that there's going to be all kinds of opportunities to include things like cloud. If you can use public cloud and 5G, for example, to move data from an instrument or data to an instrument, if you can actually control the instrument and you can automate that instrument by using cloud or private cloud or a combination of private cloud and public cloud, that's absolutely the right way to do it. I mean, public cloud has gotten much more secure and much more robust and reliable over the past few years. You can use it for many, many things. We do that here. So we have a computing system that we think of as this is birthright computing for a Oak Ridge staff member. They get access to what we call CADES, which is our compute and data environment for science. And it includes everything from desktop computing to clusters to custom architectures or public cloud. So we can burst out into Amazon Web Services if that works for you, because it's a lot cheaper. If you can use it the way it was intended to be used, it can actually be a good tool in your arsenal of problem solving.
And it fits with your ecosystem vision as well.
Yeah, that's right.
So Jeff, you paint an exciting picture about the future of HPC. You're retiring, I believe, this summer. Is that the time frame?
Yeah, so I haven't actually submitted my paperwork, but my target is July 1st. And
okay.
I chose July 1st. There's really three reasons why I think July 1st is the right time. I'm 66 years old. So, people like me that are 66 years old, our Social Security number is 66 and 4 months. And so I will have 66 and 6 months. And so from a Social Security perspective, I can go out in full retirement. Now, we don't want to live on Social Security. So I think more importantly, July 1st is my 20th year anniversary. I started at Oak Ridge on July 1st in 2002.
Oh, wow.
And so July 1st of 2022 is 20 years at Oak Ridge, and so that feels good. And then Frontier should be done, and I won't leave my successor with any unfinished business. And so all of those things contribute to me thinking that July 1st is a reasonable time.
Can we ask, do you plan to really full retirement, kick back, or keep your hand in to some degree?
No, I'm really going to retire. I mean, my wife retired. She actually started here at the lab when she was 18, right out of high school, and she got her undergraduate degrees while she was working here. And she retired actually after 37 and a half years at Oak Ridge, the age of 56, I think, is when she retired. And she retired 4 years ago. So she's been really harping at me about retiring so that we can do more things together. So I don't really plan to do anything. I'm not going to incorporate myself or go out and do any consulting or anything like that. I think I'm going to mow my own grass. I'm going to plant a garden, and I'm going to do stuff like that. And I'm going to travel a little bit. So all things that I've been looking forward to.
If you get 4 people to mow the grass, it's 4 times faster.
That's right. Or you can just put more driveways or concrete around and have less grass.
You could call it parallel lawn mowing, I guess. Right.
Yeah, exactly. I had to throw in the parallelism in there.
Yeah. So you should talk to Doug Cothey sometime. Do a conversation with him about he's got an autonomous lawnmower that he got. And so he's got some funny stories about a robot lawnmower. So.
Well, Jeff, a pleasure to be with you today, and congratulations. And thanks so much for all the great insights and stories.
Thank you. Thanks for having me.
Thank you very much. What a treat.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.